In this first lesson, we're going to start a short series of videos talking about generics. Now, generics allow you to create a flexible data structure that doesn't have its data type defined ahead of time. Instead, each time you want to create a new instance of the generic data structure, whether that's a generic collection, a generic class, a generic property of a class, a generic delegate, or some other generic data structure, each time you want to create a new instance of that, you'd pass in the data type that you want the data structure to adopt and enforce. So there's a sense in which generics are a lot like input parameters to methods, but instead of supplying a value, you would actually supply a data type. So the examples that you'll see most often in articles and in books with reference to the usefulness of generics are with collections. In fact, in .NET 2.0, all your system.collection classes, the array list, the dictionary, and so on, they have generic implementations in the new .NET 2.0 namespace, system.collections.generic. So I want to start out with a simple example just to kind of illustrate all of this and kind of walk you through the thought process of why you would want to use generics. So we might use a collection for storing a bunch of objects. So let's take the example of an array list of order items, so a collection of order items that belong to an order. So let's go ahead and run this little application. Doesn't do a lot, but it will illustrate our point for us. First of all, we're going to add 3 order items to an order, so the order will have a property that is managed internally by an array list. We'll do that right now. So we've added those 3 order items to an order. So now the items collection of the order object will be used to calculate the subtotal of all the items that are in our order. So you can see if we were to add up all the items in our shopping cart right now, it might come out to $249.80. Now we may want to just display the first order item within our order, and that would be order item ID of 123. So let's show how this is implemented. First of all, you see I have an order.cs, and I've got 2 classes defined here. First of all, I have the order class, which has an order ID and an order items field or property, as we'll expose it through a public property, and that order items is managed internally by an array list. So you can see that here we have the public getter and setter for our items property, which again is of type array list. Now that array list will hopefully, in most cases, store individual order items. So here's our order item class, and it's very simple. It just has an order item ID, the amount for the item, and the quantity that we want to purchase. So we'll multiply those together to get kind of that line item total, which we'll calculate the subtotal from. So let's take a look at the button handlers for each of our 3 buttons that we clicked. In the first button, all we did was new up an order, and then we created 3 order items and populated their properties appropriately, and then added each of those order items to the items collection. Again, that's managed internally by an array list, and then we'll just show a simple confirmation message. In the second button, what we did was get a subtotal of each of those individual items, order items. So what we'll do is for each order item in our order.items array list, we'll take the current item, multiply its quantity times the item amount, and then we'll add that to our subtotal and then display that subtotal to the user. In the third button, what we're doing simply is just to grab out the 0th or the first item within our items collection and then display the order item to the user via message box. Okay, so that's all well and good, but our array list has an Achilles heel, and that is this. If we get sloppy or somebody else comes on our development team and looks at this order.items collection and says, boy, it would be really nice if I could put in, for example, a subscription into that to that list of items, because we now have a concept of a subscription within our application. So this subscription class has a subscription ID, an amount, and a duration. Those properties are different from our order items. So what will happen? Can we add that successfully to the items collection? Well, we're going to try that in button number 4, and then if we are able to do that, then we'll give a confirmation that we were able to add that in. So let's go ahead and add order items to our order. We can even display the subtotal and view again the first item. And then now let's try to add a new subscription object to the existing order. And it worked successfully. So now internally what our array list has are 3 individual order items and a subscription. Now what happens if we were to try to get our subtotal? So we click our display subtotal of order, and we're going to get an invalid cast exception at runtime. Now the problem here is that this would not be caught at compile time, but at runtime you'd possibly get an unhandled exception. So what are our options here? How can we prevent this from happening? Well, we could wrap everything in a try-catch, but that's really just a band-aid to cover up the real problem. Ideally, what you do is create a strongly typed array list, and you certainly can do that, and we have a lot of videos in .NET 1.0 on LearnVisualStudio.net that demonstrate exactly how to do that, and that's great and everything, except that every time you want a strongly typed collection, you'd have to go and write new code. So you'd write a collection, a strongly typed collection for order items. You might create a strongly typed collection just for orders. It's not very reusable unless you wanted to reuse it to create more order item collections or more order collections or whatever the case might be. So what if there was a way that you could write that code once and never have to write it again? Just one time, it'll work for order items or orders and any other type you can think of, and have the advantage of being type safe so that we never run into this problem again. Well, in .NET 2.0, Microsoft has done exactly that. They've created generic versions of many of the collection types. And before we move on, let's just revisit this one more time just to make sure that we're totally on board here. Take a look at a more simple example using just numbers instead of order items. So let's take a look. Let's stop the running of our application here and take a look at button number 5. And here we're going to create an array list of ints. Let's take a look at what we have here. It's very simple. We'll have an array list called numbers, and then we'll just add the number 5, 7, 13, and 4. Okay, and let's see how that works. Run our application and click this here, and so we tally them all up and they equal 29. Great. Now, what if we were to uncomment out this line of code? Now when we do the for each, what do you think will happen? Well, what's going to happen here when we come across the literal string Bob? Let's go ahead and run it. I think you know the answer already. It's not going to catch it as we compile it and run the application initially. Only when we click our button and try to do that tally, we're going to get this invalid cast exception. So that's really the problem that we're trying to fix here. And when they were originally writing the 1.0 and 1.1 framework, they didn't want to restrict the collections to a particular type, so they just allowed you to stick an object in whenever you're adding items to an array list or dictionary or whatever the case might be. So to improve the stability of the array list, to disallow situations like we've just been looking at here, most people would go and implement their own list because they wanted to distinguish between a list of numbers and a list of strings or any other type that you wanted to keep in a collection. Now that was kind of cumbersome. For every single time you have a typed list, you need to go and write a new list class. There's got to be a better way than having everyone out there create their own implementation of a list of numbers, for example. So Microsoft saw this problem, and it was a good reason to implement generics in .NET 2.0. So how do we create a list and tell the list that it should only contain numbers? Well, generics allows us to do just that at the time we use it, not necessarily at the time we define it. So I don't have to go and define a new class. We're just going to use an existing one and somehow tell it when we construct it that this particular list is just a list of numbers. So to create a list that only holds numbers, we're going to use the list class, which as you can see here, let's go ahead and stop this and bring this up. We're going to comment this out and do this. So we'll go list of type integer, whoops, int numbers equals new list int. You can see in IntelliSense it already brings it up. Whoops, list int. Okay. And as I hover my mouse cursor over this list, you can see that it initializes a new instance of the system.collections.generic.list of t class that is empty and has a default initial capacity. Okay. So this is part of the system.collections.generic namespace. This is the generic replacement for the ArrayList class. And you can see that in C# we're going to tell it which type it should contain through the use of the angle brackets. Inside the angle brackets, we'll tell it the type we want it to contain. So in this case, we're going to make it an int. So there's only one class defined in the framework called list, but there's any number of types that you can create based on that list. So we can create a list of ints, or we could, in this particular case, we might do something like this: list of order items. Order items equals new list order item. Okay. Or we could do this: list string, my strings equals new list of string. So whatever you put in the angle brackets is like you're creating a new type dynamically. So let's talk about the benefit of this. Let me go ahead and just get rid of these two lines here since we're only dealing with our numbers example. And let's go ahead and try to build this project and compile it. And notice what happens now. We get compile time warnings. The best overloaded match for system.collections.generic.list.int add int has some invalid arguments, cannot convert string to int. What line is it croaking on? Well, the line where there is a problem, where we're trying to add an item that is a different type from what was declared when we instantiated our list of t and passing in the type integer. So it knows when we try to do an add with this string that that's not allowed in this case. So that's a good thing. This is an improvement over the array list. So for comparison's sake, let's do this. Let's rewrite the order and the order items example to take advantage of our new generic list collection. So you can see that this first example was generic example 1 CS. Let's open up a new project that also comes with this video, and that's generic example 2 CS. It looks exactly the same, but in this case we have implemented in our order class, we implemented the items property as list of type order item. So now let's take a look at the code for trying to add a subscription to that order. And as you can see, I've kind of got some comments in here that it can no longer do this, where we're newing up a subscription and trying to add it to the items collection of the order. Will this work? Well, let's try to build our solution here, and you'll notice that I get this problem on that line of code, basically saying that you cannot convert from a subscription to an order item, which means we passed in the wrong type here. So now our code can rely on the benefit of the list being strongly typed, and we can catch the scenario where some errant code attempts to add a different type of object to our list. And this situation is caught at compile time rather than at runtime. Also, consider how much more useful the new generic version of the array list has become. True, before we had this generic version of the collections, the old array list could accept the type object, which, as you probably know, is the common denominator from which all of the other classes derive. But this flexibility was not a good thing because of the scenario we just described. So while it was flexible, it wasn't flexible in a good way. Sure, it was usable, it worked fine for years, but it wasn't optimal, because if we got sloppy, as we demonstrated could happen just a moment ago, we can introduce something into our application that made it pretty fragile. But now, by simply using a generic version of the array list, or rather, now the new list collection, it's still flexible, but it's flexible in a good way. The application is no longer fragile, but it's both flexible and strong. And not only that, but generic collections are more efficient than the old collections. And we'll talk about why that is when we look at the new generic collections in a moment. So I want to press upon you that generics were introduced into the .NET framework to help you improve your applications, not just to add more complexity or to make your code more difficult to read. They improve your applications by increasing the flexibility of your code without sacrificing strong data typing. Okay, so the next point of emphasis that I want you to walk away with is how pervasive generics are. Regardless of the type of application that you're writing, you're going to want to come away from this series of videos knowing what generics are and how to consume them in your applications. Specifically, you'll want to become familiar with the built-in generic versions of the collections in the .NET 2.0 framework, and you'll want to know how to consume generics that were created for use in custom types created by other people at your workplace or other APIs that you want to consume. For those of you who will be constructing and maintaining APIs for your enterprise's applications, you'll especially want to know the rules and the techniques for creating your own generic collections, your own generic classes, generic methods, generic interfaces, and so on that others will consume. This makes your APIs much more flexible and strong. So in the first 8 or 10 videos or so, we're gonna focus on Microsoft's generic collections, and after that, then we're going to start to delve into creating custom classes that are generic. Thank you.